Now, I don't want to harp on this too much because I do assume that many of you have a pretty solid background in probability, but I do briefly want to touch on what are the odds of an event happening, and more specifically, how we calculate the odds ratio with regard to the probability of an event happening in the context of our logit regression. So we can think of like the odds of an event happening in the context of flipping a coin, where if we're flipping two coins, right, the probability of giving two heads in a row is going to be 1/4, and that probability of not getting those two heads is 3/4, right? And so the odds of getting two heads would just be the probability of getting two heads over the probability of not getting two heads. So the odds of getting two heads is 1/3. Or we might commonly refer to it as 1 to 3 odds. Now, when we think of the odds of an event in the case of a binary variable, so there's two possible outcomes, we can think of the odds in favor of y equaling 1 as being the probability that y is in fact equal to 1 over the probability that y is equal to 0. So this is exactly how we had constructed it previously. So we can think of an example, maybe the probability of getting a heart attack, right, is very low, but it's 0.0018. So we can rewrite that, right, as the odds of having a heart attack are 0.0018 over 1 minus 0.0018. So the odds of an event provide maybe a potentially more meaningful interpretation as the measure of association between y and x. So at least in the context of a regression, usually what we're interested in, right, is comparing the effect of a change in x on y. So we might be interested in how does moving from age group 20 to 29 to age group 60 to 69 impact or differentiate the odds ratio, right, in the likelihood of getting CHD. So we can write that, right, essentially like this. So again, we can think about like the probability of 1 over not having it over the probability of not having it over the probability of not having it. And we can essentially just rewrite this, right, as the odds of the outcome being present among individuals with x equals 1 is similar to the odds of being present amongst individuals with x equal to 0, right? So this is essentially looking at a shift from x equals 0 to x equals 1, looking at the difference in odds ratios. Now, again, going back to this example, let's think about having a heart attack as our outcome, and our two groups are non-smokers and smokers. So we can suppose the probability of a heart attack is probably a little bit higher for a smoker than a non-smoker, right? Here I've got listed that the probability of a smoker is 0.0036, and it's about half that for a non-smoker. So when we construct the odds ratios, we're actually looking at the odds of having a heart attack for a non-smoker over the odds of a heart attack for a smoker. Now, we can just essentially rewrite this, right, in probability terms. And given the fact that I know what these probabilities are, I can kind of just insert and plug and chug here. So that's essentially all I'm doing. Which we can finally see that the odds ratio is about 0.5. Now, essentially, the way we can think about that, right, is that the odds of having a heart attack among smokers is about 2 times greater than the odds among non-smokers. Now, if we extrapolate this beyond our example, again, the way that we can just think about constructing the odds ratio is the change in the odds of going from x equals either 0, whatever, to x equals x plus 1. So it's easier to think about that, right, from x0 to x1. Now, a really simple way, right, to set up the odds ratio in a way that we already know would be to do it using the logistic regression function. So going back to our example, again, we can think about the probability of having a heart attack given that someone is a non-smoker. Let's express that using what we know about the logistic function such that our equation is this. So when we're talking about the odds ratios for a logistic regression, a 1 unit increase in x going from x equals 0 to x equals 1 changes the relationship in y such that the odds of getting CHD or having a heart attack, right, increase in this manner. Now, when we're looking at the odds ratios, the way that we can interpret them is that 1, they're always going to be greater than or equal to 0. Now, if they're 1, that means the probability that y equals 1 is the same in both samples. Now, in the previous one, right, we saw that it was about 0.5 for non-smokers to smokers. Now, if the odds ratio is less than 1, that means the probability of y is less in the numerator group than in the denominator group. So that makes sense, right? In the previous example, the group that had the lower probability of having a heart attack, right, was in the numerator. Now, if the odds ratio equals 0, that means that basically can only happen, right, if there is essentially no chance of having the disease or a heart attack in the numerator. Now, to wrap up in this lesson, we went over kind of the intuition behind logistic regression. We talked about the assumptions as well as how to estimate these logistic regressions. Next time, we're actually going to go over how to interpret them and run them in R. And then finally, we'll be discussing how to assess model fit with logistic regressions as well.